Video we are going to see about segmentation and active control technique. Segmentation means breaking an image into meaningful parts, like grouping the similar pixels together is known as segmentation. Different approaches exist on segmentation. First one is region split and merging. We'll cut the big areas into smaller ones, or we'll merge the similar ones. Next, mean shift. We'll find a cluster of pixels based on the color of the image. Then cut, normalized cut or graph cut means we'll treat the image as graphs, and based on that graph we'll group the so we'll separate the group of pixels. And active contour, that is today's topic. So we'll find the curve that adjusts themselves to outline of the object. A best example is rubber band. We'll see that in active contour different methods are available: snakes, dynamic snakes, scissors, and level sets. These are the four methods we are going to see in this video. So first one is snakes. Snake is nothing but a flexible curve that start as an initial outline and evolve to fit the boundary of an object in an image. So imagine you have a image. The image may have trees or building or road with car. So and so objects will be there. So my objective is to cut only the tree or cut only the car. So in that case, I'll start initial outline. If I want to cut only the car means I'll start with initial outline and I'll focus on the boundary of the object. Then finally I'll get an entire image. In previous videos we have seen edges and lines, right? So they are focus on the complete part. If you want to find the edges of the image, every edges will be drawn and the edges can be converted into straight line. Here I'm focusing only on the particular part of the image is known as segmentation. So if you want to take only the tree, I'll start initial outlining of the tree and I'll focus on the boundary of the object until I get a complete tree. So imagine a rubber band placed in an object. So it slowly moves and stretches until it fits around the object boundary. If you wear an object around a pencil, it will be fitted to the width of the pencil. If you place the same rubber band in a mobile phone, the rubber band is flexible and it will fit the shape of the mobile phone. If you place the rubber band in a notebook, again it is possible. So similarly, I'm going to find the boundary which is fitting that object. So this is happening by minimizing three different energy functions. You know already what is energy function. So three different energy functions are internal energy, image energy, and constraint energy. Internal energy will keep the curve smooth. While drawing a boundary, it should be very smooth. It should not be too wiggly. Some wiggling means ups and downs. That should not be there. So internal energy is a mathematical function which helps to make your curve smooth. Image energy means it pull the curve towards the edges. If the curve you're drawing is somewhere out of the boundary means it will focus towards the edges of the image. Then constraint energy is optional component for user interaction. The user can add spring to pull the snake towards certain point, or we can use the repulsion to push it away from us. So I can either pull my curve towards a point or I can push it away. Sometimes we may draw the edge which touches the images also. So the edge should be in exact boundary. So I can either push or pull. So spring means we'll pull the snake towards a boundary, or repulsion means we'll push it away from the others. So E snake, final curve or active contour is also known as a snake. So it is found by internal energy, image energy, and constraint energy. All these are mathematical function. I am just representing only the final equation. And E elastic nets and slippery springs. It is used for optimization problem. One best example is traveling salesman problem. Next we are going to see about B spline and shape priors. A problem with traditional snakes is that they have too much degrees of freedom, which can cause them to stuck in wrong place. Two solution to address this is B-spline and shape rear. B-spline have only few control points, and it produces smoother curve and less error. So we can avoid the wiggling in wrong places. Shape priors means I can add knowledge to the object shape. So image means the computer don't know the name of the image. So if you feed a tree image already to the computer, if you're trying to find the segment of the tree means it will have some idea about the shape of the tree, so it can follow not exactly but it can follow the shape of the tree. Similarly, if you feed the car means it will have so and so shape. The computer will have a certain knowledge of the car already. So if you label it, if you provide the knowledge of the object shape, then the curve maybe or segmentation may be realistic. That is known as prior. We are already providing a pre-feeded knowledge into the system. So three priors are there: local prior, global prior, and shape energy. It's also known as priority. Local prior means per control point. Each point on the snake has an expected position. We add a penalty if the point move too far from this expectation. So this keeps the individual point from drifting widely. We'll focus on only the individual point. If the individual point move away from the expected position, then I can add penalty to make it to the original position. Then all point together means instead of treating a single point, we collect them into the set of vectors. We will find the mean shape as well as the covariance matrix. Then we'll apply the principal component analysis to find the main way shapes vary. So this is instead of focusing on single point, we'll focus all the points together. So example or wide face or narrow face or long nose versus short nose. We can use this global prior. Then shape energy is also known as penalty. A penalty term is added if the shape deviates too much from the typical shapes. This keeps the snakes realistic. So will prevent the face outline from turning into triangle, but also allow the oval variations. So these are the priors used to find the active contours. Next one is dynamic snakes and condensation. For tasks like tracking, moving an object in a video, dynamic snakes are used. Instead of starting from the scratch on each new frame, the snake position from the previous frame is used to predict the new location. So it is mainly focused on video processing. Here also we are going to see two methods of approaches. One is Kalman snakes, another one is condensation, also known as partial filtering. In Kalman snakes, we are assuming the system follows or the image follows a simple and consistent pattern. So Kalman filter is applied to predict the new position and then corrects the prediction using the new image data. It is done using a mathematical function, linear as well as Gaussian. So real world scenarios are often more complex. So here it is simple and pattern. We can a simple and consistent pattern means we can use Kalman snakes, but real world scenarios are more complex. They are not simple and consistent pattern. It will have some unpredictable pattern. So partial filtering, also known as condensation, is used to address the dynamic snake. So it represents the range of possible positions with many weighted particles, and it uses the image evidence to identify most likely positions. So this can handle more complex movements. So based on the weight, will process the image. Scissors, intelligent scissors is more interactive approach to segmentation. Here also the traditional sex require rough starting outline of the system that the system refines. So if you want to tree means I have to start with the outline, then only I can follow the boundary. The intelligent system refines the boundary in real time as the user draws. As the user moves the space, the system uses the Dijkstra algorithm to find the low cost path from the starting point to the current mouse position. This will create a live wire effect when the line automatically snaps to the nearest of the object. So assume you have an image. If you want to determine a car boundary means I'll start drawing the boundary of the car. After drawing the boundary, I'll get the segmented one that is known as live wire. Right. Next one is level set. The limitation of traditional snake is that they struggle with the topology change. For example, when a single object split into two objects merge, the topology change occurs because the original shape has been changed. So the level set method solves this by not tracking the curve directly. Instead, it represents the curve as a zero crossing of the higher dimension function. Zero crossing means whenever we represent the image as a pixels, we use a mathematical formula. On applying the high dimensional function, the magnitude of the value is changed, which means the positive is changed to negative means there is a zero crossing occurs. As this function evolves, the contour naturally splits or merge as needed, making it ideal for segmenting the complex shape. So here we have seen active contour technique, which is one of the methods of segmentation. We have seen snakes, dynamic snakes, scissors, and level sets. Thank you.